Good day, ladies and gentlemen. You are highly welcome to Shitu's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you to kindly subscribe to my YouTube channel. Click on the subscribe button. Hit on the bell to get the notifications anytime I drop my videos. So now, today we are going to be looking at addition and subtraction of surds. So now we have this problem on the board. But before we can be solving any problem here, we need to introduce to us what we really mean by surd. So, surd is if you have a number under this, that is square root, like square root of 2, square root of 3, square root of 7, like this. So they are called what they are called surd, because this can not give us an exact value. Understand? So that is why the 2 still remain under the square root, because if you are trying to get the square root of this, so you get unterminated values, that is, the values won't be an exact value. So that's what we are trying to say. So this is what we call surd. Understand? So this is what we call surd, or something like this. You have square root of 1, square root of 5, like that. So, but if you have something like this, square root of 8, understand? So this one can be splitted into 4 times 2. This can be splitted into what? Into 4 times 2, that is 8. So now you can see that 4 times 2, this for one of these number under the square root, one of these is a perfect square, and 4 is a perfect square. You call it perfect square, or you call it what? You call it rational. It's also rational number, because if you take the square root of 4, it will give you an exact value. But this one is irrational. We call it irrational, or if you like, you call it imperfect. That is irrational number, or what? Or imperfect, because if you take the square root of 2, so you don't have an exact value. So if you have this kind of problem, that is, you have root 8, and you are told to express root 8 in surd form, therefore you need to split 8 into 2 numbers, that is perfect square and what? And imperfect. So you take the square root of the perfect square, that you leave the imperfect inside the root. So that is that about surd. So now, before we still solve this, we start solving this, so we still have to tell us the rules that are guiding addition and subtraction of surd. So let's say we have this kind of, let's say we have m root k plus or minus n root k. So now, if we have this kind of problem, okay, let me 1, 2, we have m root k minus n root k. So now look at this one. Now the law of addition and subtraction of surds says the surds can only be added, understand, if they are alike. So now what makes these to be alike? That is, this one is alike as they are, understand? So let's say this one now can be written as m plus n root what? Root k. So what they are trying to say is that this is alike, that is, this and this, they are what? They are alike. Why? Because they are of the same form. So what is making this to be the same form is what we have. Whatever you have the same thing, maybe you are adding 2 times or 3 times of what? Of surd expression, as we have it like this. So whenever you have the same number under the square root, so you said they are alike. Like this one now, we have k under the square root and we have k under the square root, so which shows that the 2 terms are what? Are alike. Therefore you can add them as, let's say you have 2x plus 3x. You can see that this, they are alike because x. So what do you have? This one will be 5x. Same thing applicable when we are talking of what, of sort. So the same thing applicable to this. We have m minus n root what, root k, n minus n root k. So now, but here this cannot be. Let's say we have, but let's say we have m root k plus n root n. Understand? So therefore we cannot add this together, because what we have under the square root from the first term is different from the one we have in the what, in the second term. So this one, they are not alike, therefore you cannot add. And at the same time, if you have minus there, so you cannot what, you can't subtract. Are you getting it now? So those are the ideas we are going to be using, so while solving problems on addition and subtraction of sort. So now let's now use the idea we have already gotten here to solve the problem given to us. So now we try to, because we have, if root 32 plus root 128 minus root 18 plus root 50 equals to k root 2, so the answer is to find the value of k. So now how do you do that now? So let's solve. We have to solve this. So we are going to write down the question again. We have 128 minus 18 plus root 50 equals to k root 2. So now what are we going to do? We need to simplify this further to the what, to the simplest term where you cannot simplify again. Understand? So as we have so you cannot add as this, because look at this. If we are to go with the rules we have, you can see that we have different things entirely, because we have root 32 here, we have 128 here, we have 18 here. You can see whatever, all these under the square root, they are not the same thing. So if you want to follow this, so we said they cannot be added or they cannot be subtracted, but it is not like that. Before they can be subtracted or added, so you need to simplify them further where you cannot break them again. So we need to simplify this one into two numbers, that is perfect and imperfect. So like this one now, so root 32 can be splitted 16 multiplied by 2 plus this, also we have 128 can be 64 multiplied by 2. Also this one can be 9 times 2. This one can be 25 times 2 equals to k root 2. I don't know, are you following? So now from here, the next thing we'll do is try to take the square root of the perfect square and the imperfect, you put it under the square root. So now here, you can see that we have 16 here, the square root of 16, because this square root is what is having the 2, understand? Therefore you will now take the square root of the 16 ordinarily, so we have 4. Then 2 we cannot have because it's imperfect, so we put 2 under the square root. Then this one 64 is perfect, so we have 8 root 2, because the square root of 64 gave us what, 8, minus 9 times 2. You can see that the square root of 9 is what, is 3. You put this one under. Then here is what, 25. The square root of 25 is 5. We put this under. We have k root 2. We have k root 2. So now from there, what's the next thing to do? So now the next thing to do, you can see that they can be added and subtracted. You can see, because all we have under the square root are the same thing, so they are alike. You can combine them. So now let's first add this together because they are positive. 4 plus 8, what is that? We have 12. 12 plus 15, so we have what? We have 17. Then 17, okay, 17 root 2 minus 3 root 2 equals to k root 2 here. So now from here, what's the next thing to do? You can see that this is 17. So 17 root 2 minus 3 root 2. So 17 root 2 minus 3 root 2, they can be subtracted, because what they have under the square roots are still the same thing. So 2. So now therefore 17 minus 3, we have 17 minus 3 root what? Root 2 equals to k root 2. Are you following? So now, what is 17 minus 3? 17 minus 3 is 14 root 2, which is equal to k root 2. Now, so we need to get the value of k. So what do? It means you just try to divide through by what? You divide through by root 2. So divide through by root 2. So you can say this one, we cancel this one. So we have what? This one also, we cancel this one. So we have k to be what? K to be 14. So therefore, the value of k is 14. So if you want to know, or if you want to confirm whether you are right or not, so just put the value of k here. We have 14 root 2. Then try to simplify this one totally. You'll see that left hand side will be equals to right hand side. So, and that is the end of today's lecture concerning addition and subtraction of surds. So we'll be looking at multiplication, also as division, then rationalization of surds and so on like that. So now, if you have any question to ask concerning the one we just did, so kindly hit the comment box and ask. So you have a wonderful day.